Hello guys, welcome back to my channel Code by Vansh, and today we are going to solve the question letter combination of a phone. Okay, so in this question we have given a string containing digits from 2 to 9 inclusive, written all possible letter combination that number could represent. Okay, return the answer in any order. A mapping of a digit to letter, just like on the telephone button, is given down below. Note that one does not map to any letter. Okay, so as we can see in this question, like 1 is actually mapping to null. Okay, 1 is actually mapping to null, 2 is actually mapping to a, b and c. Okay, so we can see that 3 is actually mapping to d, e, f. Okay, and so on. So we can see every numeric alphabet or every numeric number is actually mapping to some strings, which is actually equal to a, b, c. 2 is actually mapped to a, b and c. Okay, so what we are actually going to do, we have given digits, and in the digits, in the question itself, it is given 2 and 3. Okay, so we know that 2 is actually mapped to a, b and c, while 3 is mapped to d, e and f. Okay, so what we are going to do, we are just going to make permutations of these. A, we will make permutations with d, so it will become a and d. Okay, a will be mapped to E. A will map to E. A will map to F. Okay, so this will be the permutation of A, D, A, E, A, F. Okay, now B is mapped to D. B is mapped to D. B is mapped to E, and B is mapped to F. Okay, like that we are also going to do for C. C is mapped for E, D, and C to F. Okay, so in total we will get 8 permutations, and here also we can see that we are getting the same permutations. Okay, so in order to perform this inside the code, how we are actually going to solve this? So when there is something like permutations, we actually do recursion. Okay, so in this question also we are actually going to do recursion, but how we are actually going to know that our digit, like our 2 is actually mapped to A, B and C? How we are actually going to do that? We are actually going to do that by the help of a data structure called hash map. Okay, so in hash map, what we are going to do, we will just store it like this for 0, for because it is like indexes. Okay, it is like indexes. So here it is 0 index, it is 1 index, it is 2 index, it is 3 index, it is 4 index, and so on. Okay, so in corresponding to 0 index, I will store nothing. This will be null. For 1 index, it will be nothing. For 2 index, what it will be? It will be A, B and C. For 3, it will be D, E, F and so on. Okay, for every letter, I will store the corresponding indexes. Okay, for 2 it is A, B, C and so on. Okay, so after that, what we are going to do? We are actually going to, as I show here, it is actually 2. Okay, so 2 corresponds to A, B and C. So 2 correspond to A, B and C. So what I am going to do, I am going to take an empty data structure. Okay, and I will first, I am at A. So what I am actually going to do, I am at A. So what I am going to do, and it is 2 and 3. So I will push it into the vector. I will push it into the A, and then I will give the function. I will give the function to basically index I plus 1 or 3. Okay, how I am going to do that, I will show you. Okay, so for it is actually A, B and C, and this is 2, and 3 is actually D, E and F. So first what I am going to do, this is empty at this position. What I am going to do, I will push A inside this, and I will do like D. Okay, like I will move further. I will go to B. Okay, and then it will move like this. First I will go to A, then I will go to B, then I will go to C, like this. And for each permutations, it will just add these nodes, and for the backtracking, I am just going to pop it out. Okay, so this is the thing. Now let's move to the coding part. In the coding part, as you can see, I have used a hash map. As I told you, it is 0, it is 1 and corresponding or everything. Then there is output, and at here what we are actually going to do, it is first, it is actually 0. Okay, so the digit index is actually 0. After that, what we are going to do, as we know that ABC has actually contained, I will pick A. After I pick A, then I will move further for the index plus 1. And then as you can see here, it is actually index. Okay, so first index is 0, then it will be 1. Okay, so it will be 1, index will be 1, and so on. So here so you can see that paired digit index is 0, so here it will give us A, B and C. But it will give A, B and C. After it will give A, B and C, what it's going to give me, it is giving me, I am just going to iterate through A, B and C. Okay, so first I will be at A, then I will be at B, and then I will be at C. And when it is at A, I will just call out the index plus 1, and index plus 1 is actually from the digit. Okay, index plus 1 is actually from the digit. So here I plus 1, if I will do here I plus 1, it is actually, it will give D, E and F, because 2 and 3. So it will go to 3, and it will print out all the combinations of 3. Okay, so it is going to do like this. Okay, so like this, it will make 3 branches, then it will move here, it will go and it will break into 3 branches, and whenever it is returning back, it will just give us the backtracking move, which is actually pop. There are 3 steps. First we push it, then we call the function, and at the end we are just going to pop it out. Okay, this is the total recursion and backtracking step. I hope you like the video. Make sure to like, share and subscribe for more upcoming videos, and thank you for watching.